Hello and good afternoon, everyone. My name is Marten Cureton. I work here at Pentasec, a part of the Charterhouse Group, as a Senior Security Analyst. And what I have prepared for you today is an accompanying video to the amazing blog written by Joshua Bernard about the recent exploit discovered called DirtyPipe that is targeting vulnerable versions of the Linux kernel. So without further ado, we're going to dive straight into the demonstration. I will caveat, the information is in the blog, that this does require another mechanism to deliver this payload to the endpoint, whether that be a previously known and exploitable vulnerability or through social engineering, as is much the case with advanced or very devastating attacks like this. But for the interest of the demo, we're going to assume that the information or the exploit has been transferred to the endpoint, and I've pre-canned a few commands in the interest of speeding up the demonstration. So the first one is to just demonstrate that we have a vulnerable version of the Linux kernel. Next one is the folder, which contains a text file with information in it and the source code of the exploit. The next one is compiling the source code into a Linux executable file. And we can see that by here, it's changed to green. And the next one is just showing you the data that is contained within the change.me.txt file. So I'm going to clear down the screen just for ease. And what I'm going to do now is do a sudo, and I'm going to try and append some data to change me. And now sudo is essentially saying run as root level. But I get permission denied. I can do cat, and you can see nothing has changed. Now, I would just like to add, I'm running this from the opt root folder, and anything that I do in this would require root level privileges. This is why this demonstration is very valuable in showing just the devastating effect this exploit could have on system files, i.e. allowing a very well-versed attacker to gain root level privileges by using this particular exploit as an additional payload after initial exploitation as a standard user. So to demonstrate that now, we're going to do this. I'm now calling the exploit, the executable file that I compiled earlier, passing it to the file changeme.txt. And number 2 is actually the data offset, which is saying start at this point in the data. So when you break it down to ones and zeros, this is saying start here at number 2. And then the data I'm going to pass to that file that I'm going to use to modify the file in question. So I'm going to execute that. I get a lovely little return saying it's worked. And we can now do a cat. Oh, so now we have something that's changed. This part. So you can see 2 actually means offset 3, 1, 2, 3. So now it's started at position 3 in the text line and modified the data within that file. And it's in a system file as well, essentially, because if I wanted to edit this file, I'd still have to be root privileges anyway. Now, if I go to another system that is not vulnerable, just for total completeness, I can show you this. I can do cat change, just like we've done before. And we can see, try and change this data. And I'm just going to be lazy and do the same thing. It says it's worked. However, change has not changed. So this just demonstrates that not every Linux kernel version is vulnerable, as sometimes it can be misleading what we get told is or isn't vulnerable. This is just a demonstration that whilst that command still worked and it believes it still worked, it didn't make any system changes. Now, what here at Pentasec are we doing about this? Well, we have Sentinel-1 as our endpoint detection response, and this is just a very quick snapshot of showing you this has actually been ran earlier on today. You can tell by the time frame on a Ubuntu system. It still worked. It still was exploitable, but actually now we have ability to detect what is actually running in terms of the commands that need to be executed from an attacker, and we then can create custom rules to detect this attack until further, more forensic level analysis has been conducted to have a more global detection mechanism for this threat. So I hope this gives you a snapshot of what we do here at Pentasec, what we can do, and use the tools to protect our clients proactively based on new and emerging threats. So I hope that's been informative, and we're always open to questions in the future.